Good afternoon, everybody, and thank you so much for the invitation. I was asked by the major whether I'm going to talk about the vision for the future. I say that to discuss the future, you probably need to either live on it or invent it. But certainly, I believe that the famous quote that the future is already here, is just not evenly distributed, it holds. And over the next minutes, I'll try to delve a little bit into it and see what are the opportunities that are coming ahead. Before starting, I'd also like to congratulate SurfNet on the 25th anniversary. I was still remembering when I did my PhD in Switzerland, and we started setting up the backbone of the multicast network, and we were trying to connect our computers to make sure that the internet that was just starting to pump a lot of content could scale well, and we could distribute a video and audio in real time. Now, what happened over the years is that that multicast network that we were hoping that it was going to boost the real-time delivery of content over the network, it actually started getting replaced by something else, something that it was more of a cooperative nature. It was peer-to-peer networks. And peer-to-peer networks, they were fundamental to a lot of the innovation that has been happening on the internet for the last decade. Here is an example of some of the innovation that happened then. It was the concept of file swarming, taking the file and dividing it into very small objects and then giving different pieces to different individuals so they could all help each other. And there were many other innovations, like, for instance, the incentives for cooperations with tit for tat, or making sure that the entropy in the system was always high, so you could find every single little bit of piece of the content that you would need. Now, if you look at the trends of peer-to-peer networks over the last years, you get a picture like this. These are the interests of people in peer-to-peer networks over the last 10 years, and you can see a declining interest on this very successful innovation that at a certain point, it carried more than 60% of traffic in a lot of the backbone networks. Is it so? Has it been really declining, or is it just integrated into everyday usage of what we do? And I think it's a little bit of the second. If you see what happened with these peer-to-peer networks, these cooperative schemes, that people started taking their computers and behaving as a very large distributed network. Now it's everywhere. It is being used as a peer-to-peer data storage, playing for Google or Amazon. It is used to help do the NAT traversal in a lot of the Skype communications and voice over IP communications. It's helping deliver music to your home through Spotify, using peer-to-peer delivery to accelerate the download of the songs. It provides anonymity for users to be able to navigate the web, or it even helps file delivery for large content distribution networks, such as Akamai. And what is the reason for this? Well, I think the reason is that a lot of people got tired of waiting for the network to support every single thing that it was supposed to support to be able to play, and try out different routing algorithms, different content-based naming protocols, anycasting, caching, indexing. Peer-to-peer networks all of a sudden became this platform where people could play. And with a very simple piece of software, you would just download it in your computer, and then overnight, you could just start testing your new routing algorithm. And in a sense, peer-to-peer started creating a new ferment of ideas that now are percolating into the future internet design, being the basis of a lot of the concepts that are now being developed with software-defined networking, with CCN, content-centered networking, and a lot of the more advanced search and database algorithms that we're seeing now in the industry. In a sense, peer-to-peer networks were a large experiment where, in the same way that Axel Rhodes started thinking about what were the right incentives mechanisms for people to cooperate and test things like the prisoner's dilemma, There were many peer-to-peer clients, each of them doing a different thing, each of them testing a different cooperation algorithm. And they started achieving completely an incredible number of sophisticated cooperation algorithms. In a sense, peer-to-peer networks have been evolving into society, and it's not only about testing out new internet protocols and algorithms, but now it is about testing out things like new coins. You get Bitcoin. How about a non-government controlled anonymous global currency? Or what about peer-to-peer lending? Or what about peer-to-peer cash sharing? Or this thing that we're testing out in Barcelona, where we are giving the users the capability to share their Wi-Fi connections with each other. And I don't mean just sharing with people that are roaming outside, but creating a mesh network where you recycle connectivity from your neighbors, and you're able to sum up the different Wi-Fi connections into one to be able to give you a lot higher speed into your home. Now, what can I say? I don't know how many of you have seen this. This is Burning Man. It's a week-long annual event. It's held in the Black Rock Desert in the northern Nevada. It fits about 50,000 people every year, and you get all sorts of experimental, radical expressions of art, self-governance, and tests for peer-to-peer experimentation. It's all great. We created a platform for development, for innovation, for creativity, and now it's percolating into all layers of society. However, this is Paul Francis. He's the director of the Max Planck Institute in Germany. And about 10 years ago, we were discussing about peer-to-peer networks, and he came up with this single slide. That he said peer-to-peer networks are doomed to failure in the way that we are building them now. And he was referring to the file sharing mechanisms that we were using at the time. And when we asked him why, he said, you know, it's economics. It's simple economics. He said, you know, you're getting increased traffic, and you increase volume, but you are not increasing revenue. Users are going to get a lot of value out of it, but nobody is getting paid extra for it. So eventually the ISPs are going to reach customer saturation, and then you're going to start getting a lot of conflicts. You're going to have conflicts between the overlay of these peer-to-peer networks and the underlay, and because there is basically no economic incentives, there are no signals for these peer-to-peer networks to work well with the underlay network. Just to give you an example, most peer-to-peer traffic in Spain is exchanged, 42% of it is exchanged within the country. However, only 20% is exchanged within a single ISP, meaning more than half of the traffic goes outside of the ISP, while the content still exists within the ISP. Now, this brings me to the next topic, because I think that on the design of the future internet, we will probably have to pay a lot more attention to the network economics part. And what I'm seeing is a wave of phases that are coming through the design of new services that if you look at what happened in the 90s, it was mostly about broadband penetration. If you look at what happened in the first decade of this century, it was about wireless broadband penetration. And we're getting into a new business cycle that is still uncertain. What is going to be the new business model? What is going to be the new applications and services? Is it going to be finance? Is it going to be e-health? Is it going to be big data? Is it going to be machine-to-machine? A little bit of everything. But we're certainly getting to that point where there is a big question mark of what is the next business going to be. And in the meantime, what's happening is we're getting an increase in traffic and a flattening in revenues, saturation in the users, flat rates, and a decouple between the benefits and the cost, which hopefully we'll be able to solve through a lot of innovation and efficiencies. But it is important to understand where are the biggest costs coming today in some of the networks. What I'm showing here is the different parts of a network, from the platforms, this would be in the data center, to the network core, to the transport layer, to the IP network, all the way into the access network. And what you can see is that more than 60% of the cost in all these components goes into the access network. So it is the very last mile that consumes more than 60% of the cost in designing an end-to-end network. And now, if you look at where the costs go into running that access network, whether it's in design and development, whether it's in the implementation and deployment, whether it's the provisioning, whether it's the supervision and maintenance, or whether it's the basic infrastructure, you will find that more than 60% of the cost go into the supervision and the infrastructure and the maintenance. So basically the operations. And the reason is simple. Supervision, maintenance, and operation don't work with Moore's law. They don't come down at the same rate, in the same way that hardware does. And it's basically because it requires human intervention, human labor, and the speed at which we become better, it doesn't improve as fast as Moore's laws. Now, there is certainly a lot of room for innovation in this space, and I'm going to give you an example of one of them. This is a virtual operator that we've launched in the UK. It's called GiveGav. It's an operator that doesn't have shops. It's 100% online. The only thing that you get is a SIM card. And the beauty of it is that we use peer-to-peer cooperation for customers to help each other serve and answer queries about operational problems. So about last year, we were able to give £1 million back into the members that help other members solve some of their problems. And you know what's happening? The average answer online is resolved within 90 seconds. And it is getting about a growth rate of 400% because users not only are helping each other, they also feel they're part of the system. Now, the other problem that we're seeing is how networks are dimensioned and what is the cost of the core network. If you see most networks and equipment gets dimensioned based on the peak capacity. It's the 95th percentile. You take the statistics every 5 minutes, you chop off a 5th percentile, and then what remains, that's how you get charged, that's how you get billed, and that's how you have to dimension by your router, set up your links, and so forth. Now, if we see what happens on the internet, and we compare it to other distribution networks, for instance, physical distribution networks. Physical distribution networks are very good at moving things in space. So they're very good at moving things by railway, by boat, by plane, by car, and they optimize all the different transits and routes to get from A to B in the minimum amount of time. We also do a similar thing on the internet. We do it in the digital space. We pay a large attention to how we route the information to make sure that we minimize delays and we optimize the routes. Now, if you look at what happens in the physical industry, in addition to moving things in space, they're also very good at moving things in time. So they have stores, they have warehouses where they keep things, where they store them for a while to make sure that they can take care of the peaks and the valleys in the supply-demand, or that they can use the most efficient routes at any point in time. So they can take it into a warehouse at an airport, keep it there waiting for the whole night, and then waiting for the chip plane that is going to come on the next day and do a chip shipment. If you see how we do that in the internet, we don't do it at all. We're missing that big component of moving things in time. We only do it at a very small time scale. We do it with TCP/IP. We have small buffers in the end systems, in the routers, that allow us to do control at very fine small time scales, but we are not able to do it in the order of hours or in the order of days. Now, you would be wondering, why is that useful? And this is the answer. Imagine that you want to ship a large volume of data, scientific data, for instance, that came out of CERN, and you want to ship it into Stanford University so they mix it with their data set and understand whether they found a new particle of God. what's happening is that this is the type of typical network behavior that you're seeing in the network. So you get some times of the day that you have a lot of usage, and then some other times of the day where the usage is very low. Now, these are 3 links in our operation network. This is one in Latin America. This is in Brazil. This other one is happening in Madrid, in Europe. And then this one is in China. Now, you imagine that you want to ship a large volume of data from Latin America into China. Then what happens is that when Latin America is waking up, so this is when Latin America is sleeping, Madrid is waking up, and then China is peak time. And the opposite happens when Latin America is on peak time, then China is going to be on the valley time. So whatever is good for one of the senders is bad for the receiver, and the other way around. So basically, you end up in this situation where you have these decoupled constraints that are time-shifted by the way the world and the planet moves, and how we keep waking up each other as the sun comes. And when we need to move data from one part of the world to another part of the day, we find these constraints. Now, what is lacking here is some storage in the network that will help us move things not only in time, but also in space. So take the data, store it in a certain location, and then wait for a while until the next opportunity to be transmitted forward opens up. And then you keep riding these valley opportunities that appear at any point in time in different parts of the network. Now, I've talked about a better network design. I've talked about some of the network economics, but certainly some of the things that will drive the next demand into networking equipment and a lot of the research and innovation will be the Internet of Things. And if you allow me, the Internet of Things now is a disaster area. It is just hold into some small deployments or for very large corporations, fitting into a car, fitting into some vending machines. But the end user, the startups, the people are not touching it yet. They're not playing, and if you want creativity, you need to open it up. This is how the Internet of Things should look. It should look like a place that is similar to the physical world and that it allows for a lot of imagination and creativity. And instead, this is how it looks today. It is a black box. It is restricted to large companies that spend a lot of money into this tailor-made equipment that it is very hard to do an open platform out of that. Now, let me tell you what we did. We got together with Arduino, which is the largest open hardware platform in the world. And we thought that a lot of people had started working with Arduino, playing with it, giving it to developers to see what is it that we could do, they could do with it. But there was something missing, and it's that they couldn't have ubiquitous connectivity. So what we did is we built a shield, a GSM shield. This is the shield that we built on top of Arduino that basically gives you roaming-free 3G and 2G connection anywhere in the world. So you can go into Arduino shop, and while you buy your Arduino hardware component, you can also buy a the SIM card with a shield that allows you to just use a plug and play and start working with it and start playing with it. Now, I'm going to show you a video of one of the things that we did. This was an experiment that we did with some designers, a couple of artists, that we asked them to think about how to use Arduino in a new way, something that had never been done before, and what is it that they could do with this platform using this 3G connectivity. Now, what they thought about, what they came up with, was how to apply Arduino to children, to toys. So they created a new toy a toy that basically is full of intelligence material, that is full of sensors, and that you sell them in pairs, you give them to kids in pairs. And one of them takes it home, and the other one could be in Latin America. But the nice thing is that both toys are connected, and they talk to each other through emotions. It is a new way of communicating. It is a new way for kids to express emotions. And the fact that it's always on, they can carry it on the bus, they can take it in the park, and both kids are always connected. So when you rub one of the toys, the other one giggles, or when you squeeze the other one, this one makes a noise. And it's this concept that if by enabling this open platform, you start thinking about things that were not possible before. Now, let me give you another example. When we looked at this Internet of Things, we realized that it was this black box. And while we were working with Arduino, we understood that the set of things that people wanted to do was immense. We could never come up with all the different use cases that people were going to do. So we started thinking about building something that it was modular, that it was a little bit of a platform. And we came up with this thing that we call thinking things. They're a bit like Lego bricks. And these different bricks, each of them has a different functionality. So one of them has a battery. The other one has a 3G connection. The other one has a temperature sensor. The other one has a humidity sensor. The other one has a pressure sensor. And then you can just combine them in whatever way you want to develop your own use case. And the nice thing is that people just come up with their own use cases and start using them every day. I'm going to show you this video. This is from a chapel in Spain, and it's this is a priest in the chapel, and basically he lives in the nearby city, and he cannot visit the chapel every day, especially when it rains or there are problems, but he wants to make sure that if there is humidity, he gets alerted, he gets an SMS. So he combined these three modules, and with a simple click of a button, he can just place it in the chapel, and if there is any emergency, if the window broke and water starts coming in, he can just go up and try to fix the problem. Taking Wi-Fi into that place was costing hundreds of euros. This solution cost about tens of euros. And now, can you start thinking about connecting not only chapels, but connecting all sorts of objects in the home, right? This is a plant that we connected a few modules, and when the plant doesn't get water, it complains on Facebook. So, so the plant has a Facebook account, and it says, please come and water me. And then when you water the plant, it actually says, I like it. So, you know, we have network economics. How peer-to-peer allow us to play into a large playground. Internet of Things, hopefully, if we open up the platform and open source the reference designs, we'll get a lot more people playing on it and inspiration and ideas. And I think the next big area where there are opportunities is probably big data. And big data in particular from the cellular phones. You know, for you to receive a phone call, somebody needs to know where you are. And for you to get charged and billed, somebody needs to understand what are the number of calls and to improve the service. Cellular phone data generates a large amount of data. Here it is, for instance, the amount of data that is generated by cellular phones in the UK alone and compared to all the Google data, and it's a very significant data. With this data, you can do things like this. For instance, you can see what are the top 10 areas in Barcelona that are visited by American tourists on every hour. And you can see which are the clubs, which are the restaurants, which are the places that they go. But you can also do some interesting things like this, where you can count the average number of days that different tourists spend in Barcelona when they come for vacation. And if you have an Airbnb apartment, then you can better target your offering, your website, understand that probably you're getting a lot more Russians coming into Barcelona, and that probably you should translate your website into Chinese Mandarin of a certain canton, because that's the type of tourists that you're coming in. And certainly, this cellular phone data will help us design smarter cities. This is a visualization of the set of places that people like me go based on the data that I have in Madrid. And basically, based on different phone fingerprints, so time of the day, location, we are able to understand how different parts of the city are either an industrial part, and that was the red part, or there are commercial places, and or this is nightlife, this is where my friends go and get a drink, or this is where you go for leisure and sports, or the next one is what type of transport is amenable for you in that city. Now, can you imagine the use for this for mayors, town halls, city planning and designing, where to place the next Starbucks? Where do you need extra police in the city? What stores should we have around Walmart? Nike brings out 60 different shoes in the stores every week. Out of these 60 stores, out of these 60 pairs of shoes, 59 get retired. With this data, we can probably help Nike decide which ones to retain and which ones to throw, just by understanding how people move in the city. But more importantly, what we're realizing is that big data has opportunities not only to help cities, but to help in the health space. We understand that there is a big correlation between diabetes and the set of your everyday habits. Which places do you visit, how much you walk, what do you do in everyday life, and not only to diabetes, but other diseases, like, for instance, bipolar disorder. The cost of e-health is about to explode by a factor of 10 in the next decade. If we don't do something about it, the cost will be unbearable. So by using big data, we can probably start walking the path of preventive health care. Bipolar disorder patients, they have these two modes. They either go into depression or they go into mania. Now, the nice thing is that if you catch them early, your chances of reducing their bad period increases by about 75%. And what happens is that as they go into this depression or mania behaviors, their communication pattern, their activity patterns changes. And this is something that doctors can spot and can give the right medication at the right time. A recent study says that doctors will be able to reduce about 600 euros per patient in medication, and that the average episode of bipolar disorder will be brought down between 600 days to about 150 days if you are able to use the patient's cellular data to be able to predict when is it going to go into remission. Now, in addition to understanding what is it that, how big crowds move, if you get a sample like this of the different spots that people are making communications on, you can start drawing trajectories of how people are moving across the different places or the cities. Now, this is an example of how these trajectories, how do you go from point A to point B, is very useful. This is the Roya fungus. It's a fungus that is killing the crops in Guatemala. It's actually the coffee plantations. And we've got together with the United Nations. We collected data in Guatemala for several months, and we're trying to understand how is it that the moving of population from Ecuador into Mexico through Guatemala can affect the spread of this virus, and where is it that the local health governments can put the most resources to try to stop this virus and killing the local economy. So that's all great, but if you look at your cellular phone data and you start thinking about it, it's actually a social network. And it's a very important social network. It is made out of people that you call, as opposed to Facebook that is made out of friends that most of the time is not sure that you're real friends, right? Now, this is my social network. This is my social network on my voice social graph. I'm in the middle, and the nodes around it are the set of people that I call, at what time and the distance to me, it means how close they are to me. And it's a graph that is not explicit, but it's implicit. And it has some nice properties. It's a universal graph because of the innovation that happened about 40 years ago with GSM, that we can all make phone calls to each other. It's a very strongly authenticated graph, so it's very hard to get another phone number as opposed to just getting a million different usernames and passwords. And a lot of private communications go through it. So it'd be interesting for me to understand how this graph looks and what is it that I can do with it. Probably, if you look at this social graph, it's probably one of the largest social networks in the world. I'd say it's the second largest social network in the world. And this graph, you probably can use it to help you define your trust and your reputation. I don't know how many of you have Clout, K-L-O-U-T, which is a company that helps you define what is your trust and your reputation based on your Twitter activity. How many people follow you, how many tweets you make, how many retweets you make. Can you imagine what would be your credit score, your cloud, based on your phone activity? And, women in the US are now picking guys based on the credit score. Would it be useful to have a good credit score? So having this information and giving it back to the customer, it is something that it is very important. It is something that if you provide value to the end consumer, if you give them the data back to them, they will be able to start using it in ways that we cannot imagine today. Why not using that trust score to find things that you like? For instance, we ran an experiment in Spain where people would opt in to share their phone graph, and we ran this search engine. This is the example for houses to rent a flat, but we ran one for nannies, where the results were re-ranked based on the distance on the voice graph to the people that were offering the flat or that were offering the nanny services. Wouldn't you have to have a nanny taking care of your children that is a trusted one, that has worked with a friend of a friend, and that has a good relationship with them? The applications are endless, and what we're realizing is that the pattern of calling predicts a lot of people's behavior. We've realized that calling connections and calling patterns change as people become more wealthy, but also change with people's moods. This is an experiment that we did where we tested the number of calls an average person makes, the average time that they take on answering a call or answering a message. The set of position that they have in the network, whether it's on the weekend or not, how long they take to reply to a dear friend. And based on that, it is very easy for you to understand how is it that you're feeling, whether you're feeling more extrovert, more conscious, more agreeable, more open. And it is important for you to have this information so you can understand what to do with it and better plan your life. So what we're seeing is that we're going in an internet that was designed for communications to an internet that is now being used for content and video, to an internet that is going to be used for data, and in particular for personal data, because we are traces of bits. Every time we do something on the internet, we leave our whereabouts, our trails of activity. And what worries me is that if the data is the new oil, who owns that data, and how about privacy? Kundera used to say that police destroy privacy in communist countries. The journalists did it in democratic countries, and people themselves are losing a taste for a private life and a sense of it. I believe if we take that data and give it back to the consumers, we create a platform and they can experiment, they're going to be able to get a lot of value from it. And it is important that consumers understand about themselves as much as others understand about them to decide how to take the next steps. Now, I think this is important from a regulation point of view. So if you see what's happening in the EU and in the US with the EU Data Human Rights and the US Data Bill of Rights, the right to be forgotten, the right of portability, how to enable data transparency, traceability, revocation, fingerprinting. What happens when you die? Will I write a will on my data? Who will I donate that data to? Will I leave it for my dear friends so they understand how I live my life, what decisions I took in the tough times? What I envision is that we're going to be moving from the computer as a platform to the cloud as a platform, to the individual as the digital representation of itself as a platform. And to do this, we are running an experiment in the city of Trento, where we are asking people to opt in to live in the future. We actually give them mobile phones, hundreds of families, and we ask them, do you want all your information to be recorded? And we're going to give it to you, and we're going to give you some applications and services, so you better understand what value you can get out of it. And why not? Maybe you can take your soul and sell it to the devil. This is the example of a Kickstarter, a person that recorded everything that he's doing, and he's putting it for sale on the internet. He already got 193 people trying to buy it, and he's getting about $2,000 for everything he browses, everything he sees. I don't know if I have a video, but I'll try to show it to you right now.
Hi, I'm Federico Zagno, and here is all of my own data. Since February, I've violated my own privacy, and I've recorded my online activity, which includes the website I visit, what I post, the video I watch, what I buy, my emails, my chats, and more. I've generated so far 1.5 gigabytes of text, which is equivalent to 1,500 books, and I've taken 30,000 photos. Meanwhile, corporations have been using my data for their own profit. They use and they sell my data. Often, we don't understand that by signing the terms of services, we give away the rights to all our own data. In 2012, in the US, the ad revenues was $30 billion. In 2013, the estimates are for $40 billion. In 2012, I personally made $0. So, is my personal data worthless to me? I'm selling my data for $2. For $2, you get an entire day worth of data bundled in a single folder, which includes the website I visit, an image of my face looking at the computer taken every 30 seconds, a screenshot of the page that I was looking at, my GPS location, the position of my mouse, and a log of the application that I was using. Your contribution will give you access to my data and will allow me to finish a browser extension and an iPhone app that allows you to do the same. If more people do the same, one day marketers might pay us for our own data. If you're interested in selling your own data and turn them into a profit, please support this campaign. Thank you for your support.
We wrote a paper about this about a couple of years ago, and we call it "For Sale Your Data by You." And we found similar results where some people were willing to sell their data, and the amount of money that you were getting, it varied. But it's an important question. How much is your information worth? How it dilutes over time? What is the importance to different people? I think we're getting into this era where we're going to have some of those debates, and what we're doing in Trento in this living lab is going to try to answer some of those questions. And then finally, I wanted to discuss a little bit about how is it that all this internet thinking, all this innovation can actually help not only our industry, the digital industry, innovate and reinvent itself, but other industries. Can we use this internet thinking for others to do creativity? And it's not only, if you see the opportunity, it's massive. This is the amount of revenues that exist in internet connectivity today. It's roughly about 3% of the GDP. If you look at the amount of revenues that exist in the internet advertising, it's about 0.7% of the total GDP, a much smaller fraction. But if you look at the potential opportunity in helping other sectors like security, the financial, the public administration, the health sectors innovate, it's huge. It's about 6% of the GDP. A small improvement that we do there will go miles into having a lot of benefits. Now, why is it that I'm bringing this? Because I want to give you a couple of examples of things that our internet thinking, our design, and the learnings that we had over the last years on peer-to-peer networks, on designing complex networks, can have into these industries. This is a map of the internet that probably a lot of you have seen many times, but what you haven't seen many times is this other type of network. This is a network that is not a network of computers. It's a network of people. It's a network of soccer players. That if you start thinking at it from a networking point of view, very interesting things happen. I'll tell you what we're doing. We're working with FC Barça. We are gathering data of where every single player and the ball is in the soccer stadium every 10th of a second. We do this with high-definition cameras, and they take the information and then they convert it into a dot, into a square. And then we're trying to see what type of strategies work well and which one they don't. And we started realizing that when we talk to the soccer team, that a lot of the strategies that they use, they look very similar to the strategies that we used to design the internet. They used to play with a very centralization organization, right? It was a very hierarchical. Everybody used to pass to the middleman. And now they play a lot more peer-to-peer. We start understanding that all this tit for tat and the tiki-taka that Johan Cruyff implemented in Barca, they have a lot in common. And the question now is, what do they have to do next? Barca just got scored 7-0 in 2 consecutive matches from Bayer. What is it that, where do they go next to innovation? What we're looking is that by understanding the properties of this graph, by bringing network science and internet innovation into this field, we can help them innovate. We've realized that the teams that are higher entropic, meaning that the probability of understanding where is it that you're going to send the ball next do better. The teams that have high centrality do worse because you create bottlenecks. We are looking at different matches, how the different teams can create denial of service attacks and try to steal the ball from each other. And we are seeing how, for instance, greedy approaches, which we all know very well from networking, that tend not to be optimal, are not optimal in soccer either. It's not about taking the ball and running in front and trying to score as fast as you can. Most of the times it's about holding the space and optimizing the space rather than trying to minimize time. Now, I'm going to give you another example. I don't know how many of you know about El Bulli restaurant, but this is a restaurant that closed down about 2 years ago. It was the best restaurant in the world for 5 years in a row. You had 2 million bookings every year, and only 8,000 people could dine. You were eating for about 5 hours, a 35-course meal, and has been described as the most imaginative generator of focusing in the planet. I'm going to leave you with this video so you have a glimpse of it.
ejemplo, uno cuando va a comer en un restaurante de vanguardia, hay lo que se llama la moción creativa. ¿Sabes? Una cosa es qué bueno es, tal, y otra cosa es una moción que, joder, esto es flipante. No.
¿Cuántas horquillas? Vale, esto es aquí. No me maneja, ¿eh?
Això ja fèiem, no?
Aquesta, no?
Champiñón sí. ¿No? Yo he probado champiñón.
No sé si són dos platos o uno. Dos, al favor.
Soroll és emocionant. O soroll con la pell de gallina. És mi brutal. És mi brutal.
Sí, és que no sé per què no ho fem abans, això.
So, we, the most creative restaurant in the world, shuts down, comes and talks to us and said, I know I have to reinvent myself. I want to reopen as a foundation and a creativity lab for Cuisine in 2 years, but I don't know how technology can play here. So we started thinking about how to use our capabilities to help a new industry, like it is the cuisine industry. And we started thinking how our big data capabilities could start helping this industry. What you're seeing here is all the recipes of El Bulli from 1994 to 2001, and the different, based on the ingredients and the different combinations that were made. Now you would ask, why is this useful? If you see, it looks like a living organism. And what it can help you understand for a chef, it starts understanding immediately what type of combinations they've made, but more importantly, what set of combinations they've never made. And if they want to create a new dish, what is it, the set of ingredients that they can combine to make a new creativity. I'm going to show you a video of a little bit of how we went on this process, because
Cuando
the most important
Telefónica
thing
me comentó para ser embajador de la marca,
was the language,
Telefónica
how we're
Solar,
talking to each
una
other.
empresa de 200.000 personas, es la responsabilidad que para mí quedar bien con ellos, ¿no? Es decir, que ser ético, honesto, pues una responsabilidad. Al final la innovación, la creatividad es una actitud en la vida. Es levantarte por la mañana y hacer cosas. Gracias a la tecnología, el Bulli Foundation tiene sentido. ¿Sí? La gran cuestión es el compartir. el conocimiento. Un plato de la historia del bullying como restaurante. El espíritu del bullying, estos abrazos, ¿sabéis cuál es, no? Pasión por lo que haces, compartir, libertad y riesgo. El bullying se transforma, no se cierra.
So for me, the most important thing out of this video is that sentence that he said, without technology, el bully wouldn't make sense. The new bully wouldn't make sense. And that is an opportunity for us to take technology, to take new industries, and help them transform themselves, help them find new ways of creating, new ways of thinking. I just want to show you a couple of slides more where what we realized by analyzing these recipes is that the way the brain works is by it gives you joy if you discover something new. So if you just eat every day the same thing, it's something that you know. It makes you feel home, but it doesn't give you any surprise. So what you see here is some statistics about how traditional cooking happens. And what happens in traditional cooking is that traditional cooking shares a lot more flavors, but the set of unexpected flavors is very low. If you look at what happens with el bulli, it's completely the opposite. The set of expected flavors is low, and the set of unexpected flavors is very high. And with doing this, you can start thinking about doing database design, doing visualization design, and doing all the tools about network science that we know how to do to be able to help this industry finish. The first result of this collaboration is something that I want to show you, and that I'll close it in there, because I think it gives an example of how bringing technology and IT and helping other industries can really change some of the opportunities forward. It is called Bullipedia. It is a database for chefs to be able to create new dishes and share them with the world. Okay, so I've talked about many things. I truly believe that the future is already here. It's just not evenly distributed. Giving you a glimpse of how we probably need more and more spaces to play. I think all these networks, SurfNet and the rest, have played a great contribution to this community. We need more things like peer-to-peer networks that help crowdsource movements to foster creativity. Network economics is going to become something to take an eye on and keep a look. And then three things: Internet of Things as an open platform, big data, especially from cellular phone networks, and start rethinking about our industry. Not so much focus on ITC, but as a basis for the rest of the industry to innovate and cooperate. And finally, start brushing up your multidisciplinary skills, because as you see, you will probably need them. Thank you so much. I think there is time for maybe 1-2 questions. Yeah?
Maybe they are so frightened by the word you are describing that they are not willing to raise any question. But I don't see any. Oh, there is one there.
So Barça will keep winning, by the way.
It's working.
Tell me, why is the last mile 60% of the total cost of the network infrastructure?
Right. I think you can understand it very well if you think about it like a tree. Right. If you think of a tree, the set of nodes in at the bottom, the leaves, is a lot higher, and therefore the complexity increases, because you have first a much larger set of links at the edge, and they're very distributed. Plus also, I think in the last mile is where the online meets the physical world. So you have to dig roads, and you have to go and if a wire gets cut, you need to send somebody there. If there is humidity in a station, you need to go and fix it. And that starts dealing with a lot of the physical economy, which is about human labor. And then the other component is the service and attention. So if you have a 24/7 calling center, it requires a lot of personnel. People don't like talking to machines. A company like Telefonica, probably 200,000 employees, about 100,000 are on call centers to provide a 24/7 online support. And since it's they're handling a part of the network infrastructure that is critical, you need to make sure that it's up and running and that you provide that support. So again, I think it's the penetration, is the density that you have of lines and equipment, the fact that you have to go many times into the home. So sending an employee into somebody's home costs about 60 euros to fix the equipment, and there are still a large amount of population that are not technology savvy. And then this density combined with the support is what brings all that cost up. I'm not saying there is no room for innovation. I think there is a lot, and hopefully we'll see more about self-configuring managed networks from the edge and simplifying some of the equipment in the home, but that's where we are now. Yes.
The one thing I was surprised to see missing from your talk of innovations and so on falls into the category, I guess, of wearable hardware to perform enhancements for the human body or prosthesis for the human body. The Google Glass is probably the current device of interest in this space, but everything from prosthetic limbs to sight or hearing enhancement devices, things like this.
If I understood your question, you were talking about hardware in the body, right?
In, on, around, that act as personal digital assistants kinds of.
Yes. So that's a very interesting one. I think the phone will probably start becoming a hub for a lot of connectivity devices. So I carry this one that monitors how many steps I walk, and it wakes me up on the right sleep cycle. Last week I was in California. I was looking at the Google Glasses, and certainly we're seeing more and more of these devices coming up, and they will bring some good things. So, for instance, the glasses are great for security, surveillance, but certainly will raise some privacy concerns, and it becomes a lot easier to take a picture or to take a video. But all these body enhancement, augmented realities through extended hardware, I think that's something that will come, especially with the mobile phone as a hub that will provide connectivity and that it will carry the heavy weight of all the battery and being the communication hub.
Thank you, Pablo. I think we have to finish here because otherwise we will be too late. Thank you, Pablo, for this